In this video, I'll cover the last of the operations that we're going to be covering early on in the semester, which are Boolean and relational operations, as well as operations with regard to doing input and output. Okay, so to start with, we're going to switch to a prettier version of this code. Okay, here we are. We have the code on the left, and I've already compiled and ran the code for the output on the right. Okay, so let's walk through what's going on in here. So the first thing that's going on here is we have two different variables, one called bool true, which its value is true, and note how you specify true and false is with a lowercase t and a lowercase f. That's a little bit different from Python, so make sure you notice that. So bool true, its value is true, bool false, its value is false, and we also have some integers here, some long integers specifically. Okay, so in this first output, it outputs bool true and the result of bool true, and bool false and the result of bool false. So true is represented with the number 1, false is represented with the number 0. Even though we say true and false, true is really the number 1, false is really the number 0. It's just C++ likes representing booleans with 1s and 0s. And then if you output bool alpha, remember the name bool alpha here, what it does is it means that in the future, whenever you're counting bool values, instead of saying 1 and 0 like it did right here, it's going to say true and false. Note, this line and this line are exactly the same, except this line is after I turned on bool alpha. Okay, so next here, let me make this a little bit bigger and make this a little bit narrower. Okay, great. Next we have here is what happens if you and. This is the 2 ampersands is a short-circuiting and. I'll talk about that in a little bit. If you do true and false, it's basically saying is both the left-hand side and the right-hand side true. Well, this side is true, but this side is false. So what is the result from that? It's false. You can also say and with and like in Python. However, almost everybody who writes C++ code would use ampersand instead of and. And so I strongly recommend using ampersand as well, just to match them. But if you see code that writes them out in words, you can do that as well. You also have the OR operator, which is represented by these 2 vertical pipe characters. And so OR says if the left-hand side or the right-hand side is true, the result of this expression is true. And so here the left-hand side is true, so the result of this whole expression is true. Or you can write OR with OR. Alright, if you want to do negation, meaning the opposite, you use the exclamation point, the bang. And so this basically, the result is the opposite of whatever the expression here is. So bool true is true. What's the opposite of true? False, which is here false. You can also say not, just like in Python, to negate the value. Same thing. Okay. The other more complicated behavior that we want to talk about is short-circuiting. So the OR operator and the AND operator only evaluate the right-hand side if they need to. So what do I mean by that? So here, what is first equals 100 means we're assigning the value 100 to the location first. Now, what's the result of this expression? Remember, the result of an assignment is the right-hand side. So the result of this whole thing is 100. Is 100 true or false? Well, I haven't actually told you that, but the answer is 0 is false. Everything else is true. Is 100 everything else? Absolutely. So is 100 a truthy value? The answer to that is it absolutely is. So OR just checks if its left-hand side or its right-hand side is true. Well, if its left-hand side is true, then does it need to look at the right-hand side? No, it already knows what its answer is. The result of this expression will be true, and it doesn't even need to look at this right-hand side. And so, when running this expression, it will set first to be 100, but it won't even run this code. So if you see here, first started at 0, Now it's 100. Second started at 0, and it's still at 0 even after this line. And if you look over here, you can see that the right here, so first they both start at 0. After this line, first is 100, second is still 0. Okay, so we're setting both of those to 0 again. And then we're going to be doing outputting that they're both 0. See them both being 0 here. And then we're going to do AND here. Now what AND does is it looks at its right-hand side. 0, or first equals 0. What's the result of this expression? Well, the side effect is changing first to hold the value 0. Okay. The return value for this expression is 0. Is 0 true or false? Well, the only thing that's false is 0. 0 is false. So does AND need to look at its right-hand side? And the answer to that is no. It doesn't need to go to its right-hand side because AND checks if its first thing is true and the right-hand side is true. But if this is false, AND already knows what the result will be. If this is false, you can't, the result of AND will have to be false as well. And so it doesn't even run the second side. So first will be 0. But the second will stay at 0 because we didn't change it. Now, if I just said first equals, 7, 7 is a true value. And so then AND will also run the second thing, and that will change it. And so then if this were here, if this was a 7 here, then the result of this code would be a 7 and a 200. All right, let's go back to the slides. Alright, so once again, here's stuff that I already told you while we were looking at the code, but here I am saying it with nice bullet points. So, Boolean expressions are expressions that return true or false, which in C++ is 0 is false, 1 is true, and every other non-zero integer is equivalent to true. And once again, note that true and false here are lowercase. And there are other Boolean expressions besides the ones that I showed you. For instance, there are relational expressions. So age is less than 40. This returns a Boolean. It returns either a 0 or a 1. If age was 10, is 10 less than 40? That is true, which is, in C++, the number 1. All right. So there are logical operators, which are used to combine two different Boolean values, or values that can be interpreted as Boolean values, and which is represented with ampersand, ampersand, or which is represented by the two vertical bars, and not, which is the exclamation point. And you can combine these together. So for instance, in this line right here, 0 is less than or equal to my int, and my int is less than or equal to 3. So the AND here will run this code. If this is true, then it will run this code. And so this is how you would say, hey, I want my int to be less than 0 and my int to be less than 3. Well, that's not a particularly exciting a value. Here you can say, I want my int to be less than 0 or my int to be less than 3. And here you just say negate, give me the opposite of my int. Now, if you're not comfortable with and, or, and not, here's a little truth table that says, if P is true and Q is true, not P is false. P and Q is true. P or Q is true. If you're uncomfortable with these operations, you definitely want to make sure that you're familiar with them. We'll be using them a lot. Okay. Now, once again, as I showed you in the code, Python does support the spelled out AND, OR, and NOT. However, this is very much not commonly written in C++. I strongly recommend using ampersand, ampersand, pipe, the vertical bar character twice, or the exclamation point to represent these expressions. That's what people will be used to if they're reading or writing C++ code. All right, so here's some more code, so let's switch over to the editor. Okay, here we go. So we have some Boolean values here. The const you don't really need to worry about. It just means that, hey, these variables are not going to change their state. Don't need to worry about that for now. Okay, so the first thing we output is an end line. Oh, look, there's a nice little blank line there. And we're outputting bool is bool T is 1, bool F is 0, right? Because that's what we initialize them to, 1 and 0. Remember, true is a 1, false is a 0. And then we have some integers 3 and 8. So is this integer equal to this integer? Double equal sign are checking if they're the same value. This isn't assignment, this is equality. Two very different things. They look very similar though. Are these two integers equal to each other? No, which is a 0. Are they not equal to each other? They are not equal to each other. This results in a true value, a 1. Is 3 less than 8? True. Is 3 less than or equal to 8? True. Is 3 greater than 8? False. Is 3 greater than or equal to 8? False. And then here, if we see out bool alpha, and I just copied and pasted all of this code again, it's showing you the exact same values, except instead of saying 1s and 0s, it says false and trues. All right, back to the slides. So there are a lot of relational operators that say how two values relate to each other. And once again, if you programmed in any language, you should be comfortable with all of these. There's less than, there's greater than, there's equality, equal to, and there's not equal to. The exclamation point equals. Not is the exclamation point. Equal is part of that equality. You also have less than or equal to and greater than or equal to. So if you have the expression my int is less than 7, well, the result depends on the value of my int. If my int is a 5, is 5 less than 7? That's true, or in Python, 1. The other thing is you can also use characters. Once again, characters are denoted with those single quotes. So if the value of a character is a capital A, you can check, is that character equal to another character, which capital A is if you say capital A equals capital Q, the result of that is false because they aren't the same character. Now, one thing to be really careful about is checking floating points. So when you're doing work with floating points, there can often be little bits of imprecision because, once again, you can't represent an exactly precise number generally with a fixed width floating point. And so you have to be really careful if you're doing things like, if you say 1 divided by, 1.0 divided by 3, that's 0.333 repeating. If you multiply that with 3, the result might not exactly equal 1. It might be 0.999 repeating. And so be very careful when you're comparing like equality or inequality with values and floating points. Generally, the better idea is to say like, is my value within 0.1 distance of a 1, to say like, is it close enough to 1? We won't be doing a lot of stuff with floating point math in this class. Just be very aware of the fact that floating points aren't infinitely precise. Another thing to be very careful about is when you want to do compound expressions. So in Python, you can say things like 0 is less than or equal to my int, which is less than or equal to 3. When you're trying to say, I want to allow 0, 1, 2, and 3, if my int is any of those things, my int will be true. This expression will be true, I should say. Now, the problem is that C++ does not read it that way. What C++ does is it does precedence. So it would say, okay, less than or equals, that has a left to right precedence. And so it would put in parentheses like this. So let's pretend my int starts at 5. So is 0 less than or equal to 5? Well, that's true. 0 is less than or equal to 5, which means the result of this is true, which is a 1. Is 1 less than or equal to 3? That's also true, which means this whole expression will be true if my int is equal to 5, which is probably not what you intended. What you probably intended was to say, hey, I want to see if 0 is less than or equal to my int, and my int is less than or equal to 3. And the way that you do that is you have to actually be explicit. You actually have to write those two expressions. 0 is less than or equal to my int, and my int is less than or equal to 3. So what do you need to take away from this? Well, assignments return values. We've been showing you this over and over again. When you say x equals 4, you can chain that. You can use that as part of a logical expression. You can do that with short circuiting and things like that. The other thing to note is that false is 0 and true is a 1, and everything else is interpreted as a true value. Now, the last thing, the thing that I already showed you in the code, but I'm going to show you here in bullet points, is short-circuiting. So when you have the and or expressions, they are checking if their left-hand side and the right-hand side is true. But if their left-hand side is false, then and doesn't have to look at the right-hand side. And it's the equivalent with or, except if the left-hand side is true, then it doesn't have to look at the right-hand side because it already knows its value. So when you're doing short-circuiting, once again, this is an example that was already in the code, but we'll go through it again because we want to make sure we're all clear on this, is you only evaluate the right-hand side if it's necessary. So if first and second start off at 0, but we're assigning 100 to the variable first, the result of this expression is a 100, which is a true value. True values with or, you don't even have to look at this right-hand side because it already knows the result of this whole thing will be true. And so the output for first will be 100. The output for second will be 0 because this expression will not run. And here it is for and. This is showing short-circuiting where it doesn't have to evaluate the right-hand side. If they both start off at 0, first is equal to 0. The result of this expression is a 0. And is checking if both the left and the right-hand side are true. But if the left-hand side is already false, no reason to look at the right-hand side. So first will be 0 and second will also be 0 because this line will not run. Now, one thing I want to strongly recommend to you guys at this point is don't use short-circuiting. You know, it's better to use, we'll talk about if statements in a little bit. It's better to be explicit saying run this, and then if that's the case, then run this. Short-circuiting is complicated, it's confusing, it's even easy for people like me to screw things up. So I want you guys to know what short-circuiting is. There'll be times when we use it sparingly, but generally it's best not to use it. It's kind of more of a trick. It's more of a way to write very fast, succinct bits of code, but to be honest, it probably causes more bugs than is worth the hassle. All right, so now we're going to be switching to talking about doing more advanced things with outputting and controlling how outputting works. So we're going to switch over to the editor. Okay, here we are. There's a lot of output, but it's actually relatively simple to follow along. There's a lot of names that we're going to be using up here, some from the IOStream library, some from the IO manipulation library, but we'll show you what those names mean as we get to them. Okay, so in our code, we have a double, pi, should be a number that you might know, and we have a Boolean here. The default mode for outputting floating point values is scientific. So here I'm just outputting the name scientific to just set it to scientific already. This isn't necessary because it's the default, but you know, I'm showing it here anyways. And so now when I output pi in scientific notation, what it does is it outputs the number and the, times 10 to the whatever. Now, if you want it to be fixed, meaning you don't want times 10 to the whatever, you can use fixed notation. So here, if you put output fixed, it outputs 3.14, and they won't ever have exponents. It might have leading zeros. It might be 0.00047 or something instead of saying 4.7 times 10 to the negative 3. Okay, and the number of digits that it outputs is kind of, I'm not sure how it actually figures out the default, but if you care about how many digits it actually outputs, what you use is the set precision function, and you tell it how many digits you want, and this object you output to see out. So by saying set precision 3 here, it says give me 3 digits after the decimal point for all floating point numbers that you output henceforth. So here it would say 3.142. Okay? Now, generally, these are kind of the things you're going to want to be using, but sometimes you want to organize your text a little bit nicer. And so the way that you can do that is you can do things like justifications. Like, when you're using a Word document, if you right justify, it means the text will be all crammed to the right. If it's left justified, it'll be all crammed to the left. There isn't a centered justification, however. Okay, so by saying outputting the word right, it means the stuff they are outputting should be justified as far to the right as possible. And then it's saying set W is saying set the width of the next thing that's going to be output to take up 10 characters in space. And it's going to, by default, fill in the additional characters if it doesn't take all 10 with just the space character. So when you output hi mom here, it means make this thing take up 10 characters. And this is, I'm just highlighted 10 characters here. But make it right justified, so the hi mom will be to the right. If you didn't have this right here, hi mom would be to the left, and then there'd be spaces after hi mom. And this is saying set with 10 for by, and so here is another 10 error. Here's another 10 characters here, but by is right justified. All right. Now, if you use the set fill function, what this does is says, hey, instead of defaulting to just a space character, now whenever you're filling things, use the asterisk character. And so now here's the exact same line again. And it's the same, you know, right justified hi mom and right justified by here. But one thing to note here is that here we did left justification, and so the by here is back to the left like default, and then the space filling, which here is asterisk, is filled in over there. And then the last bit in this code is once again just demonstrating what bool alpha does. Once again, if you're outputting booleans by default, it outputs ones and zeros. If you want it to output true or false, you need to put out bool alpha. All right, back to the slides. So there are a lot of objects that you can send to streams to have them change the behavior of streams. We talked about left, right, bool alpha, set precision. We'll be showing those off again here. What these do is they change the state of the stream to have it behave differently. And this is mostly persistent in that, like, it's saying, okay, for the rest of the use of this stream, it's going to be in this mode unless it's changed again to something different. Okay, so fixed says for all subsequent floating point numbers, make sure that they are not using scientific notation, that they're just saying like numbers dot other numbers. So if you want it to be in scientific notation, you output the scientific object, and that will say, okay, I only want scientific notation, and so it'll always say like number point, none other numbers, you know, e to the whatever. Set precision is used with the fixed value to say how many digits after the decimal point do you want to be displayed. Note this is from the IO manip library. And there's bool alpha to say Boolean should be represented with true and false, and there's no bool alpha to turn it back to the default of representing booleans with 0 or 1. There's also left and right that says, okay, align things to the left, align things to the right. These are things you're going to be wanting to use with set with, which I'll show you in just a little bit. There's also, what I didn't show in code because it doesn't come up all that often, show point, no show point. Show point says whenever you're outputting a floating point value, you must include the decimal point. So even if the floating point value is like the floating point value 3, you should always say like 3 point to make it clear that this isn't an integer. And no show point means, you know, you don't have to show the point if there's not a fractional part of the number. Set with says that the next thing that's going to be output should have a minimum width of this size. It's often used for nicely when you're trying to make tables and you're trying to align things nicely in order. Now, if the next thing that's going to be output takes up more space than whatever the size you allowed, that's fine. It can always take up more than that, but if it's any smaller, then there's going to be padding to make it fill that space. And then the set fill takes in a character, and it says, okay, if you want to fill that space with something other than the space character, this is the character to fill it with. Though, to be honest, the space character is usually what you want. All right, so one last thing before we close up on operations is I just want to show you a very common mistake that pretty much everybody who learns C++ does at least once, often multiple times. So we haven't taught you guys if statements yet, but it's probably not too hard to figure out how they work. You say if, you have a conditional, and then you have some code that runs if that conditional is true. So here, if we are initializing the value x to be, or the value 5 into the location x, here we're saying x equals 1. What that means is you're assigning the value 1 to x. So now x has the value 1. Is 1 a true value? Sure. So it means you do something. Now, what you probably meant, whoever wrote this code, which actually was me, they probably meant to put 2 equal signs here. We're trying to check if x is equal, is the same as 1, not trying to change x to be 1. Now, because in C++, assignments are expressions, meaning that they can be put in places where you're expecting a true or a false value, this code is legal. It compiles, it runs. This line here will always be true because 1 being assigned to x always results in a true value, but you probably meant to be asking for a conditional to see if x is equal to 1, not set x to be 1. Common mistake, but I want to make sure that you're aware of it.